William King was the first professor of geology and mineralogy at the opening of Queen's College Galway in 1849. He enjoyed a distinguished career in geology, published many papers and made many valuable contributions to geology and the study of fossils, paleontology, and he was honoured in 1870 by the conferring of the first honorary doctorate Science DSc by the then National University of Ireland. My name is John Murray. I work here in Earth and Ocean Sciences, which is a part of the School of Natural Sciences in NUI Galway, and I teach paleontology and evolution to students at all years during their undergraduate degree. This plaster replica here is a replica of the specimen of the original Neanderthal skull, which was unearthed in the Neander Valley near Dusseldorf in Germany in 1856. Sometime between 1856 and 1863, Professor William King acquired this and made a very careful study. And on the basis of that study, he stood up at the 1863 meeting of the British Association for the Advancement of Science in Newcastle upon Tyne and proposed that this was sufficiently different from modern humans to warrant its inclusion in a separate classification, a separate grouping. Modern people belong to the group Homo sapiens. King proposed that this should be classified as Homo neanderthalensis. And that was a very significant moment because that was the first time ever that anyone had proposed a new form of human based on actual fossil remains. And King today remains the first person to ever name a new extinct group of humans. And essentially at that moment, the science or the study of human evolution, it really began in earnest. Because when scientists accepted that different groups of humans, different forms of humans had existed in the past, essentially at that point, they accepted that human evolution had taken place. The plaster replica which King examined was of the top of the head. So essentially here we're looking at the very top of the skull. If we take a more complete reconstruction of a Neanderthal skull, we can see the differences. We can see, first of all, what's missing from the specimen which King worked on. So this is a replica of a Neanderthal skull. On this side, we have a replica of a modern human skull. So this is Homo neanderthalensis, this is Homo sapiens. And when you look at the two, you can immediately see some big differences. On a modern human, we have a very big forehead. You can see the point where the brain case is quite elevated. It's much more sloping back on the Neanderthal skull. Neanderthals themselves, they have longer and lower skulls than modern humans. But despite this difference, the brain size is the same in both species. Other differences to note, Neanderthals had very big faces. Big eye sockets here, big voluminous nose, and their teeth and their mouth are all very much pulled forward. This is quite different to what you see in modern humans. And there are numerous smaller little differences too. For example, in modern humans, when you look at them, there's no gap here at the last molar between the teeth and the jawbone. In Neanderthals, you'll see there is a pronounced gap, which is referred to as the retromolar space. So you can see, when you examine the fossils themselves, there are some similarities, gross similarities, but at the same time there are differences. And that research question, the relationship of Neanderthal people to ourselves, is one of the longest standing questions in the history of human evolutionary research. And that's a question which William King started set the ball rolling in 1863 when he proposed that Neanderthals were a separate species to modern humans.
My name is Heinz-Peter Nassauer. I'm a professor in biochemistry here at NOI Galway. And the whole story of Neanderthals and modern humans recently got a total different twist, that by using new techniques like ancient DNA sequencing, we now know the total DNA sequence of this Neanderthal, and by comparing the two, we found out that the Neanderthals are not extinct. They still live in us, and we contain 2 to 4% of the DNA. That's a total unexpected and surprising detail and knowledge, and we can use this even today to study the impact on our human health of moderns. The medical background is very important, and we can also say that they have a very important impact of our human evolution.
So as you can see, in the spirit of collaboration between paleontology and fossils, so what they can tell us versus what we can extract both from modern humans and fossil humans in terms of their DNA, a story has emerged which we never really could have imagined. A story in which Neanderthals, they're not extinct, and they're actually much more closely related to ourselves than we had previously ever imagined.